Picture this: a blinding flash splits the night sky, outshining every star in its wake. For a few fleeting weeks, it burns brighter than the moon, visible even in daylight. To ancient civilizations, this wasn't just a cosmic spectacle. It was a message from the gods, a portent of doom or divine favor. These were supernovas, the violent deaths of stars, etched into history not just as astronomical events, but as myths, prophecies, and turning points in human culture. From the Chinese astronomers who recorded them as celestial omens to the Native American tribes who wove them into creation stories, these explosions became more than light in the sky. They became part of who we are. Today, we know the science behind these dazzling bursts. A supernova marks the final, fiery breath of a star, scattering elements like gold, iron, and even the building blocks of life itself across the cosmos. But here's the fascinating twist: our ancestors, without telescopes or equations, captured truths about these events that resonate with modern astronomy. They saw patterns, told stories, and passed down wisdom that sometimes aligns eerily with what we've discovered centuries later. What if these ancient myths weren't just folklore but a different kind of science, a way of understanding the universe through the lens of human experience? This is where our journey begins, where the untold histories of celestial phenomena collide with cutting-edge discovery. We'll trace how cultures across the globe interpreted the same stars in wildly different ways, from the Babylonians who mapped the heavens to the Polynesians who navigated oceans by them. We'll uncover how a supernova recorded in ancient China might explain a mysterious artifact in Europe, or how a Native American legend about the Pleiades cluster mirrors what telescopes reveal today. Along the way, you'll see how science doesn't erase these old stories. It illuminates them, revealing layers of meaning we're only beginning to grasp. So let's dive into the cosmos, not just as observers, but as storytellers, connecting the dots between what was once myth and what we now call fact. The stars have always been more than distant lights. They're a mirror, reflecting humanity's endless curiosity about the universe and our place within it. Long before telescopes or satellites, ancient civilizations turned their gaze upward, charting the night sky with nothing but their eyes and an insatiable curiosity. The Babylonians, over 3,000 years ago, etched precise star positions onto clay tablets, tracking planetary movements with a mathematical rigor that still astonishes astronomers today. Their records weren't just data, they were coded messages from the gods, blending celestial patterns with omens that shaped empires. Meanwhile, the Egyptians aligned their pyramids with uncanny precision to the belt of Orion, turning stone into a mirror of the heavens. For them, the stars weren't just points of light, they were the souls of pharaohs, guiding the dead to immortality. Half a world away, the Maya built observatories like the one at Chichen Itza, where staircases mimicked the serpent's descent during equinoxes, a fusion of architecture and astronomy. Their Venus tables, predicting the planet's cycles with near-modern accuracy, dictated everything from harvests to wars. And then there are the stories like the Greek myth of Orion, the hunter forever chasing the Pleiades across the sky. What seems like a simple tale actually preserved crucial knowledge. The cluster's visibility marked planting seasons, while Orion's rise signaled winter's approach. These weren't just legends, they were survival manuals written in starlight. What's truly remarkable is how these cultures, separated by continents and centuries, arrived at similar truths. The Polynesians navigated vast oceans using star paths, while the Dogon people of Mali spoke of Sirius's invisible companion star centuries before telescopes confirmed it. How did they know? Some call it coincidence, but others see a deeper thread. A universal human impulse to decode the cosmos, whether through myth or mathematics. Today's astronomers still rely on their groundwork. The Babylonians' meticulous logs helped reconstruct ancient supernovas, while Mayan calendars refine our understanding of celestial cycles. The line between their myths and our science was never as clear as we thought, just different ways of asking the same eternal questions. Take the story of Perseus, the legendary hero who slayed the monstrous Medusa. His tale isn't just etched in scrolls, but across the night sky itself. The constellation Perseus, with its distinctive curve of stars, hangs near Andromeda, the princess he rescued, her celestial form stretched eternally among the stars as if still chained to her mythical rock. To the ancient Greeks, these weren't just pretty patterns, they were a celestial storyboard connecting human drama to the cosmos. But look closer, and you'll find something astonishing. The myth of Andromeda's sacrifice might actually encode a real astronomical event. Some scholars suggest the sea monster she was offered to could represent the constellation Cetus, while the rock she was tied to mirrors the way certain stars align along the horizon during specific seasons. This blending of myth and sky wasn't just poetic, it was practical. Greek astronomers like Hipparchus, working in the 2nd century before the Common Era, didn't dismiss these stories as mere fiction. Instead, he mapped over 850 stars, noting their positions with precision that would shape astronomy for centuries. His work laid the foundation for Ptolemy, whose star catalogue, the Almagest, became the astronomical Bible of the ancient world. Though we now know their Earth-centered model was flawed, their methods were revolutionary. Ptolemy didn't just record stars, he calculated their movements, predicted eclipses, and even accounted for the wobble in Earth's axis, a phenomenon called precession that takes 26,000 years to complete. What's often overlooked is how these Greek thinkers straddled two worlds. They didn't erase the old myths, they built on them. When Ptolemy described Orion as a hunter with a belt of 3 bright stars, he wasn't just repeating folklore, he was anchoring mythology to measurable reality. The constellations became a bridge, linking the intuitive storytelling of the past with the budding rigor of science. Even their mistakes reveal brilliance. Ptolemy's geocentric model, though incorrect, was so mathematically elegant that it accurately predicted planetary motions for over 1,000 years. So how did medieval scholars, armed with these Greek texts, begin to see beyond them? The answer lies in the quiet persistence of curiosity. Monks in European monasteries painstakingly copying Ptolemy's works, Arab astronomers refining his star maps, and eventually, the daring few who dared to question whether Earth truly stood at the center of it all. The myths didn't disappear, they transformed, reminding us that every scientific leap begins with the stories we tell about the stars. In the dimly lit scriptoria of medieval monasteries and the bustling courts of Islamic scholars, the stars were never just distant lights. They were storytellers, omens, and even political tools. This was an era when the lines between astrology and astronomy blurred so completely that even the most brilliant minds saw no contradiction in studying both. Take al-Biruni, the Persian polymath of the 11th century, who meticulously calculated the Earth's circumference with startling accuracy, yet also penned treatises on how planetary alignments influenced human fate. His work epitomized the dual nature of medieval celestial study, a dance between precise observation and the enduring pull of ancient myths. Celestial events weren't merely academic curiosities, they shaped history. When Halley's comet streaked across the sky in 1066, it was interpreted as a divine sign foreshadowing William the Conqueror's victory at Hastings. Chronicles of the time describe it as a fiery star, its tail like a sword pointing toward England, as if heaven itself endorsed invasion. Centuries later, the sudden appearance of a supernova in 1572, now known as Tycho's star, sent shockwaves through Europe. Astronomers like Tycho Brahe scrambled to measure it, while astrologers warned it heralded the downfall of kings. Even Copernicus, whose heliocentric model would eventually topple the geocentric worldview, began his revolution cautiously, framing his sun-centered universe in language that still nodded to Aristotelian cosmology. Yet beneath these astrological interpretations, a quiet rebellion was brewing. The same tools used to cast horoscopes, armillary spheres, astrolabes, and painstaking star charts were also refining humanity's grasp of celestial mechanics. Arab astronomers in observatories like Marrakech corrected Ptolemy's errors, while European scholars rediscovered forgotten Greek texts, their margins filled with skeptical notes. The comet of 1456, for instance, was widely blamed for the plague, but a handful of physicians began tracking its path, wondering if it was merely a natural phenomenon. This tension between seeing the heavens as a mirror of human drama or a puzzle to be solved set the stage for a seismic shift. By the time Galileo trained his telescope on Jupiter's moons, the old world of celestial omens was crumbling, but its legacy lingered. The myths and fears woven into medieval star charts didn't vanish. They were repurposed. Kepler, who formulated the laws of planetary motion, still earned his keep casting horoscopes for royalty. The night sky, once a canvas for gods and portents, was becoming a laboratory, yet the stories it inspired never really left us. They simply found new forms, hidden in the equations and epiphanies of the scientific revolution about to dawn. Galileo's hands trembled not from the chill of the Paduan night, but from the impossible sight before him, 4 tiny stars perfectly aligned near Jupiter, shifting positions night after night. These weren't stars at all, he realized, but moons orbiting another world. With that single observation in 1610, his crude telescope didn't just magnify the heavens, it shattered the crystalline spheres of Aristotle's cosmos, where everything was supposed to revolve obediently around Earth. Yet Jupiter's moons proved celestial bodies could dance around other centers, upending a world you held sacred for millennia. But Galileo's most damning evidence came when he turned his lens toward Venus. If Aristotle was right, Venus should wax and wane like a crescent moon, never showing a full phase. Instead, Galileo saw it glowing round and bright, then shrinking to a slender curve, proof it orbited the sun, not Earth. Church scholars refused to even look through his telescope, dismissing the findings as optical illusions. One cardinal famously declared, "The heavens are unchangeable as Aristotle teaches." This man seeks to make riddles of scripture. The backlash was swift. Galileo's books were banned, and he spent his final years under house arrest, a cautionary tale for those who dared challenge tradition. Yet amid this tension, another mind was quietly revolutionizing celestial mechanics: Johannes Kepler. His breakthrough didn't come from a telescope, but from an obsession with geometry. Convinced the universe was built on divine harmony, Kepler spent years trying to fit the planet's orbits into nested platonic solids, those perfect shapes revered since antiquity. It failed spectacularly, but in that failure he stumbled upon something far more profound: the elliptical orbit, a revelation scribbled in the margins of his notes as if even he couldn't believe it. His 3 laws of planetary motion, published between 1609 and 1619, stripped away the last vestiges of celestial perfection, revealing a universe governed not by myth but by mathematical precision. What's often forgotten is how deeply these pioneers were entangled in the old world even as they forged the new. Galileo framed his discoveries in language that flattered his patrons, comparing Jupiter's moons to the Medici dynasty. Kepler, while deriving his laws, still cast horoscopes for nobility to fund his research. The scientific revolution wasn't a clean break with tradition. It was a messy, reluctant divorce, with each step forward met with resistance not just from institutions, but from the weight of centuries of belief. By the late 17th century, the stage was set for a new era. The telescope's eye had pierced the heavens, Kepler's math had tamed the planet's paths, and a growing network of scholars from the coffeehouses of London to the salons of Paris began treating the cosmos not as a divine puzzle, but as a system to be measured, tested, and understood. The Enlightenment's cold, methodical gaze would soon turn skyward, but not before one final clash between the old myths and the new science, a collision that would redefine humanity's place in the universe forever. Isaac Newton's apple didn't just fall, it rewrote the cosmos. When he proposed that the same force pulling fruit to the ground also kept the moon in orbit, he didn't just demystify celestial motion, he revealed a universe bound by invisible threads of gravity. Yet for all its mathematical elegance, his law of universal gravitation carried an almost mythic weight. Action at a distance, the idea that objects could influence each other across the void without touching sounded less like physics and more like magic. Even Newton himself struggled to explain it, famously writing, "I feign no hypotheses." This paradox lies at the heart of Newton's genius. The man who reduced planetary orbits to crisp equations also spent decades chasing alchemical secrets, convinced that ancient texts held clues to transforming base metals into gold. He pored over biblical prophecies, calculating the exact date of the apocalypse, and saw the universe as a divine cryptogram waiting to be decoded. To Newton, gravity wasn't just a force, it was evidence of a cosmic order echoing the harmony Pythagoras heard in the music of the spheres. The same mind that gave us calculus clung to the idea that the solar system's stability required occasional divine intervention, a notion later scientists would dismiss, but one that reveals how deeply myth and science intertwined even in the Enlightenment. What's often overlooked is how Newton's gravity mirrored older cosmologies. The Babylonian god Marduk imposed order on chaos by fixing the stars in their paths, just as gravity choreographed the planets. Hindu texts described planets held by invisible cords of air, not so different from Newton's unseen force. His breakthrough wasn't just a rejection of ancient ideas, it was their evolution, translating celestial harmony from poetry into predictive power. Yet this fusion of the rational and the mystical didn't end with Newton. Later scientists like Faraday and Maxwell grappled with their own versions of action at a distance, fields and forces that seemed just as mystifying as gravity once had. Even Einstein, who replaced Newton's equations with relativity, spoke of space-time curvature in terms that bordered on the metaphysical. The deeper science probes the universe, the more it confronts the same awe that once filled star maps with gods and monsters. Perhaps that's the untold lesson of Newton's apple. That wonder isn't the opposite of understanding, it's the spark that keeps us reaching for the stars. For centuries, comets streaked across human consciousness like flaming daggers in the night omens of plague, war, or divine wrath. The Romans saw them as Caesar's ascending soul, while medieval Europe trembled at their appearance, etching terrified accounts of hairy stars that foretold the Black Death. Even as late as 1810, when Napoleon's forces marched toward Moscow, Halley's comet blazed overhead, interpreted by soldiers on both sides as a sign of impending victory or doom. These celestial wanderers seemed the very definition of chaos, unpredictable, untamed, and utterly terrifying. Then came Edmund Halley, a man who dared to impose order on the chaos. Poring over historical records in 1705, he noticed striking similarities between comet sightings in 1531, 1607, and 1682. His audacious hypothesis: these weren't three different comets, they were one and the same, returning every 76 years like clockwork. When his predicted reappearance in 1758 came true, it marked a turning point. Comets weren't harbingers of fate, but celestial bodies governed by the same gravitational laws as planets. Halley's breakthrough transformed them from supernatural specters into calculable phenomena, though the public's superstitions proved harder to dispel. Case in point, the Panic of 1910. As Earth passed through Halley's comet's tail that year, newspapers warned of cyanogen gas poisoning the atmosphere, sparking a frenzy. People sealed windows with tape, bought comet pills from charlatans, and even hid in caves. Astronomers' assurances that the tail was vanishingly thin did little to calm fears, proof that myth often outweighs facts in the human psyche. Yet that same year, a curious shift began. Photographs of Halley's comet appeared in newspapers worldwide, its fuzzy nucleus and wispy tail rendered not as a divine portent but as a scientific specimen. The comet became a shared global event, observed through telescopes rather than interpreted through scripture. Fast forward to 2014, when the Rosetta spacecraft did the unthinkable. It chased down a comet, deploying the Philae lander onto the icy surface of 67P. For the first time, humanity touched one of these ancient wanderers, analyzing its water isotopes and organic molecules. The discoveries were staggering. Comets contained amino acids, the building blocks of life, and their water bore a different chemical signature than Earth's oceans. This upended the long-held idea that comets delivered our planet's water, suggesting instead that asteroids might have been the primary carriers. Yet they still held another secret: their pristine ices and dust were cosmic time capsules, preserving material unchanged since the solar system's birth. Today, we stand on the brink of a new revelation. As missions like Japan's Hayabusa 2 and NASA OSIRIS-REx bring back samples from asteroids, we're piecing together a startling possibility. Comets and asteroids might have seeded Earth not just with water, but with the organic ingredients for life itself. The same celestial bodies once feared as destroyers could hold the blueprint for our existence. It's a poetic twist. The hairy stars of legend, stripped of their supernatural terror, now whisper the origin story of everything we know. Imagine the moment the sun vanishes at midday daylight, snuffed out like a candle, stars glittering in an ink-black sky, and the temperature plunging as if winter arrived in seconds. To ancient cultures, this wasn't just an astronomical event. It was the universe unraveling. The Norse believed the wolf skull had finally caught the sun, while the Chinese saw a celestial dragon devouring it whole. In Vietnam, people thought a giant frog swallowed the sun, while the Batamaliba of West Africa interpreted eclipses as the sun and moon fighting, urging communities to resolve conflicts. The responses were as dramatic as the myths. Drums pounded, arrows shot skyward, pots clanged to scare off whatever beast was stealing the light. But buried in these stories was a thread of astonishing intuition. The ancient Greeks, by the time of Hipparchus in the 2nd century before the Common Era, had already deduced that eclipses were shadows. Earth blocking the moon during lunar eclipses, or the moon blocking the sun. They even predicted them with surprising accuracy using the Saros cycle, a repeating pattern of eclipses they'd identified. Fast forward to May 29, 1919, when a total solar eclipse became the ultimate test for Einstein's theory of relativity. As the moon's shadow swept over Principe and Brazil, astronomer Arthur Eddington photographed stars near the sun's edge. Their positions appeared shifted exactly as relativity predicted, proving gravity could bend light itself. The same phenomenon that once terrified civilizations now confirmed one of science's greatest breakthroughs. Today, eclipses are less about fear and more about frontier science. Researchers use these fleeting minutes of totality to study the sun's corona, its wispy outer atmosphere that's normally drowned out by glare. During the 2017 eclipse across America, citizen scientists mapped temperature drops, while biologists documented animals behaving as if night had fallen, bees returning to hives, crickets chirping at noon. The awe hasn't faded, it's evolved. Modern eclipse chasers travel the globe not to banish dragons but to witness one of nature's most precise spectacles, the moon's shadow racing across Earth at over 1,000 miles per hour, its path calculated down to the second centuries in advance. Yet even now, eclipses bridge myth and science in unexpected ways. The sun's corona, with its ethereal tendrils, resembles the descriptions of sky serpents in Mayan texts. The sudden chill and eerie silence mirror accounts from ancient Babylonian astronomers who wrote of the world holding its breath. Perhaps that's the real magic of these events. They remind us that curiosity, whether sparked by dragons or data, is what propels humanity forward. And as we turn our gaze to other solar mysteries like the violent flares that could one day disrupt our technology or the quiet variations in sunlight that might influence climate, we're still chasing the same fundamental question: what power, what beauty lies hidden in the heart of our star? To the ancient Egyptians, the sun wasn't just a star. It was Ra, the falcon-headed god who sailed his golden bark across the sky each day, battling the serpent Apophis in the underworld each night. His journey explained sunrise and sunset, but also something more subtle: the sun's occasional dimming or reddening, which priests interpreted as Ra's wounds from his nightly battles. Today, we recognize those shifts as sunspots and solar flares, violent eruptions on the sun's surface that release energy equivalent to billions of atomic bombs. Modern heliophysics reveals these as tangled magnetic fields snapping like rubber bands, but the Egyptians weren't entirely wrong. Their myth captured the sun's dynamic nature, its cycles of destruction and renewal, in a way that resonates with our understanding of stellar activity. Half a world away, the Inca worshipped Inti, a sun god whose radiance sustained crops and empires. Priests at Machu Picchu tracked solstices with precision-cut stones, aligning temples so sunlight would strike sacred niches only on the longest day of the year. When the sun dimmed unexpectedly, likely due to atmospheric ash from distant volcanoes, they performed rituals to strengthen Inti, offering gold and maize to restore his vigor. It's a poignant parallel to modern space weather monitoring. Just as the Inca sought to appease their deity, scientists now track solar storms with satellites like SOHO, the Solar and Heliospheric Observatory, whose instruments peer into the sun's churning atmosphere. These storms can fry satellites, knock out power grids, and bathe astronauts in dangerous radiation, proving the sun's moods still shape human destiny, even if we no longer call them divine. Consider the Carrington event of 1859, when a solar superstorm ignited telegraph wires and painted the skies crimson as far south as Cuba. Had it happened today, it could have triggered global blackouts lasting months. Ancient cultures might have seen this as Ra or Inti's wrath, but satellites now give us something even more powerful: prediction. SOHO ultraviolet eyes catch flares before they erupt, while NASA Parker Solar Probe dives closer to the sun than any spacecraft before, tasting the solar wind's charged particles. What would sun worshippers make of our discoveries that their deities are actually a churning ball of plasma, where hydrogen atoms fuse into helium at 15 million degrees, releasing the light that fuels all life on Earth? Perhaps they'd recognize the awe in our equations. When researchers model the sun's convection zones or measure its oscillations, they're mapping the same rhythms once attributed to gods. The difference is scale. Where myth saw intention in every sunspot, science reveals a star following physical laws, yet no less magnificent. The sun's violence births the auroras that dance at our poles. Its steady glow allows photosynthesis, the foundation of our food chain. In that sense, the old prayers weren't misguided. They were the first steps toward understanding our dependence on a force far greater than ourselves, a truth as radiant now as it was when Ra first set sail across the sky. The moon has always been more than a rock in the sky. It's been a mirror for humanity's dreams, fears, and ceaseless curiosity. To the ancient Greeks, it was Selene, a radiant goddess who drove her silver chariot across the night, her gentle light a counterpoint to the sun's fierce blaze. Her love for the mortal Endymion inspired poets, while her phases marked sacred festivals. But crossed the Atlantic, and the moon took on a wilder guise, Coyote, the trickster of Native American lore, who stole it and tossed it into the sky to illuminate his pranks. These weren't just stories, they were frameworks for understanding the cosmos, blending wonder with practicality. Farmers from Babylon to the Andes planted crops by the moon's phases, believing its waxing and waning pulled on water in the soil just as it tugged the tides. Then came July 20th, 1969, when Neil Armstrong's bootprint erased millennia of myth in one dusty step. The Apollo missions didn't just land on the moon, they transformed it from a celestial deity into a scientific goldmine. Suddenly, those seas once thought to hold water were plains of ancient lava, and the craters weren't scars from cosmic battles but records of asteroid impacts older than life itself. The rocks Apollo 11 brought home revealed the moon was likely born from a cataclysm, a Mars-sized object smashing into early Earth, hurling debris that coalesced into our satellite. The same moon that guided harvests now helped us unravel Earth's violent infancy. Yet science didn't strip the moon of its magic, it deepened it. Lunar eclipses, once feared as omens, became celestial ballets predictable to the second. The man in the moon turned out to be basins of frozen magma, while the moon's far side, forever hidden from Earth, proved strangely smooth, lacking the familiar dark plains. And when modern researchers discovered water ice hiding in shadowed polar craters, it echoed old legends of lunar moisture, except now that water could fuel future colonies. This shift from myth to mission didn't end with the moon, it simply redirected our gaze. Mars, the blood-red wanderer named for the Roman god of war, inherited Earth's mythic imagination. Early astronomers like Percival Lowell mapped canals he swore were built by a dying civilization, while sci-fi writers populated the planet with invaders or ancient ruins. Today, rovers like Perseverance scour its dunes for microfossils, and helicopters like Ingenuity buzz its thin air. The stories haven't disappeared, they've evolved, trading gods for geology, but still asking the same timeless question: are we alone in the cosmos? The moon taught us to see celestial bodies as places, not just symbols. Now, as we peer at Mars through robotic eyes, we're writing the next chapter in humanity's oldest story, the dance between what we imagine and what we discover. Mars has always worn its violence in plain sight, a blood-red stain against the night, shifting direction erratically like a warrior changing tactics. To the Romans, this was Mars Ultor, the avenger whose angry glow foretold battle. The Babylonians called it Nergal, god of plague and war, while Hindu texts linked its crimson hue to Kartikeya, commander of the divine armies. Even the planet's two tiny moons, Phobos and Deimos, were named for fear and panic, the twin sons of Ares in Greek myth. This wasn't just poetic coincidence. The ancients saw Mars as a celestial mirror of humanity's darkest impulses, its color echoing blood spilled on battlefields. Then came the telescopes, and with them, a new kind of myth-making. In 1877, Italian astronomer Giovanni Schiaparelli mapped what he called cannoli on Mars's surface, mistaking natural ridges for channels. But it was Percival Lowell who turned speculation into obsession. Peering from his Arizona observatory in the 1890s, Lowell became convinced these were artificial canals, built by a dying civilization to funnel water from polar ice caps. His elaborate sketches showed a global irrigation network sparking a frenzy. Newspapers ran headlines like "Martians build canals," while H.G. Wells penned War of the Worlds, imagining Mars as a dying planet launching invasions to steal Earth's resources. For decades, the idea of Martian engineers gripped the public, blurring the line between science and fantasy. The truth, when it came, was both quieter and more profound. When Mariner 4 flew past Mars in 1965, its cameras revealed not canals but a cratered wasteland. Yet beneath the disappointment lay clues to a far richer story. By the 21st century, rovers like Curiosity and Perseverance found something Lowell never anticipated: dry riverbeds, ancient lake beds, and mineral deposits that only form in water. Mars hadn't been built by engineers, it had been sculpted by rivers, some wider than the Mississippi, that flowed billions of years ago. The red planet wasn't a symbol of war, it was a fossilized water world, a place where life might have once taken root. Now, the question isn't whether Martians built canals, but whether microbes once swam in those vanished seas. If future missions uncover fossils or even dormant life in subsurface brines, how would that rewrite our cosmic mythology? Would Mars become a cautionary tale, a warning of what happens when a planet's climate collapses? Or would it transform into a symbol of resilience, proof that life clings on even in the harshest corners of the universe? The myths we've draped over Mars have always said more about us than the planet itself. As we sift its sands for signs of our own origins, we're not just exploring another world, we're rediscovering what it means to be alive in a vast, mysterious cosmos. Jupiter doesn't just rule our solar system by size, it commands our imagination with the same ferocity as its namesake, the Roman king of gods. Those swirling bands of cream and ash aren't mere clouds. They're a celestial throne room where storms rage with winds topping 400 miles per hour and lightning strikes 100 times more powerful than Earth. At the heart of this chaos spins the Great Red Spot, a hurricane so vast it could swallow our planet whole. To ancient astronomers, this crimson mark was Jupiter's all-seeing eye, a symbol of the god's omniscience. But when the Juno spacecraft slipped into orbit in 2016, it revealed something even more astonishing. This eye is a churning maelstrom, a storm that's likely raged for at least 350 years, its roots plunging 200 miles beneath the cloud tops. The same tempest once mythologized as divine wrath is now a laboratory for understanding atmospheric physics, with Juno's data suggesting Jupiter's storms are fueled by internal heat, not sunlight, a revelation that rewrites how we think about gas giants across the cosmos. Yet Jupiter's greatest disruption to human thought came not from its storms but from its moons. When Galileo first trained his telescope on the planet in 1610, he spotted 4 tiny stars flanking it in a perfect line, stars that moved. Night after night, they shifted positions, sometimes vanishing behind Jupiter or crossing in front. These weren't stars at all, but satellites orbiting another world, a direct challenge to Aristotle's doctrine that everything revolved around Earth. Galileo's sketches of these Medicean stars, named to flatter his patron, became bullets in the scientific revolution's arsenal. The Catholic Church condemned his findings, but the truth was undeniable. If moons could circle Jupiter, then Earth wasn't the universe's immutable center. What Galileo couldn't have guessed was how strange these moons would turn out to be. Europa, its icy shell cracked with reddish veins, hides a global ocean twice the volume of Earth's seas, warmed by tidal forces as Jupiter's gravity squeezes it. Io, the solar system's most volcanic body, spews sulfur plumes 300 miles high, its surface constantly remade by eruptions. Ganymede, larger than Mercury, boasts its own magnetic field and possibly subterranean seas. These aren't just moons, they're worlds, each with environments that could, in theory, harbor life. The same celestial bodies that shattered medieval cosmology might one day answer whether we're alone in the universe. And then there's Saturn, Jupiter's jeweled rival, whose rings once baffled astronomers as utterly as Jupiter's storms. Galileo, peering at their odd ears through his primitive scope, assumed they were two large moons. It took Christian Huygens in 1655 to identify them as rings, though he imagined them as solid disks. Today, we know these are countless ice particles, some as fine as dust, others as large as houses, all dancing in precise orbits. But the real mystery lies in their origin. Are they the shattered remains of a moon torn apart by Saturn's gravity, or primordial debris left over from the planet's birth? The Cassini mission's final act, plunging through the rings in 2017, revealed surprises like ring rain, a shower of icy particles falling into Saturn's atmosphere. Even now, these rings whisper secrets about the early solar system, their shadows sculpting storms in Saturn's clouds below. From Jupiter's tempests to Saturn's icy halos, these planets remind us that the myths we once wrapped around them weren't entirely wrong, just incomplete. The ancients saw kings and gods. We see complex systems governed by physics, yet both perspectives share the same awe, the same hunger to understand the forces shaping our cosmic neighborhood. And as probes like Juno and Cassini peel back layer after layer, we're left with a humbling truth. The more we learn, the more the universe invites us to keep questioning. Saturn's rings first appeared in Galileo's telescope as two blurry ears, flanking the planet, mysterious protrusions he couldn't explain with the astronomy of 1610. By the time Dutch astronomer Christian Huygens peered at them 45 years later, better optics revealed their true nature, a dazzling, flat ring system suspended around Saturn like a cosmic halo. To 17th century observers, this seemed almost divine, a celestial jewel case, as if the heavens themselves had crafted the perfect ornament. The myths weren't far behind. Some imagined them as the shattered remains of a moon, others as frozen remnants of a primordial nebula. The rings became a canvas for human wonder, their ethereal glow inspiring poets and scientists alike to ask, how could such fragile beauty exist in the void? What Galileo and Huygens couldn't know was just how intricate this jewelry really was. When the Cassini spacecraft arrived in 2004, its cameras captured rings so finely detailed they resembled grooves on a vinyl record, thousands of individual bands, each sculpted by the gravity of Saturn's moon. Some strands twisted like braids, while others split into spirals or sported bizarre propeller shapes, evidence of tiny moonlets plowing through the ice. The particles themselves ranged from sugar-sized grains to house-sized boulders, all glinting with pristine water ice so pure it reflected sunlight like a mirror. This wasn't just debris, it was a dynamic, evolving system where tiny collisions and gravitational nudges choreographed an endless dance, but the real showstopper lay beyond the rings. Cassini's cameras spotted geysers erupting from Enceladus, a small, icy moon no one expected to be geologically active. These weren't just plumes, they were towering fountains of water vapor and organic compounds, shooting 80 miles into space from cracks near the moon's south pole. As Cassini swooped through these jets in 2015, its sensors tasted salt and silica, hints of a global ocean beneath Enceladus's icy shell, heated by Saturn's gravitational squeeze. Suddenly, this tiny moon joined Europa as a prime candidate for extraterrestrial life, its hidden seas possibly warmed by hydrothermal vents not unlike those that nurture Earth's deepest ecosystems. The irony is delicious. Saturn's rings, once seen as mere decoration, turned out to be a gateway to something far grander. Their delicate structure is shaped by unseen moons, their composition hints at ancient cosmic collisions, and their shimmering ice might share a kinship with the watery depths of Enceladus. As we turn our gaze to other ringed worlds like Uranus with its tilted rings or the faint, dusty hoops around Jupiter, we're left wondering what other planetary marvels hide in plain sight. Maybe Neptune's moon Triton with its nitrogen geysers holds similar secrets, or perhaps the faint rings of distant dwarf planets whisper tales of forgotten moons. One thing's certain, the universe adorns itself in mysteries, and Saturn's jewels are just the beginning. Uranus and Neptune were the great unknowns of the ancient sky, hidden beyond Saturn's glow, invisible to the naked eye. By the time astronomers spotted them, the pantheon of Greek and Roman gods had already been parceled out to the classical planets. Uranus, discovered in 1781 by William Herschel, broke the mold twice, first as a new world beyond Saturn, and second with its bizarre sideways spin, rolling around the sun like a celestial barrel. Naming it proved tricky. Herschel wanted Georgium Sidus to flatter King George III, but astronomers eventually reached back further than Jupiter or Mars, to Uranus, the primal Greek sky god, father of the Titans. It was a fitting choice for a planet that defied expectations. Its icy blue-green disk tipped 98 degrees, likely from a colossal collision in its youth. Neptune's story is one of mathematical triumph. When Uranus's orbit wobbled unpredictably in the 1840s, astronomers calculated an unseen planet must be tugging on it. French mathematician Urbain Le Verrier pinpointed Neptune's position on paper before Johann Galle spotted it through a telescope in 1846. Named for the Roman sea god, Neptune lived up to its moniker. Voyager 2's flyby in 1989 revealed a world of sapphire storms, where winds scream at 1,500 miles per hour, faster than a jet fighter. These aren't just breezes, they're supersonic rivers of frozen methane, sculpting cloud tops that dance above an ocean of superheated water and ammonia, a mantle so pressurized it forms diamond rain. What Voyager 2 found at Uranus was no less startling. Where Neptune blazed with tempests, Uranus lay eerily calm, its pale cyan face unmarked by storms, a quiet giant with a secret. Beneath its bland exterior, the planet's tilted axis creates the solar system's most extreme seasons. Each pole basks in 42 years of continuous sunlight, followed by 4 decades of darkness. Meanwhile, its moons are a frozen menagerie. Miranda, a shattered jigsaw of cliffs and canyons, looks like a world glued back together wrong. Teutonia bears scars of ancient geysers that might once have spewed water. Then came the hammer blow to planetary tradition, Pluto's demotion in 2006. Once the 9th planet, it was reclassified as a dwarf planet, a decision that sparked outrage. School children wrote protests, astronomers debated, and cultural whiplash set in. Yet the controversy revealed something profound: how deeply we anthropomorphize the cosmos. Pluto wasn't just a frozen rock, it was Mickey's dog, an underdog world we'd grown to love. New Horizons flyby in 2015 only deepened the mystery, showing Pluto's heart-shaped glacier of nitrogen ice, mountains of water ice towering over frozen plains, and even evidence of a subsurface ocean. The same public that mourned Pluto's planetary status now marveled at its complexity, proving that labels don't diminish wonder. From Uranus's silent tilt to Neptune's diamond gales, These ice giants remind us that discovery isn't just about finding new worlds, it's about rewriting what we thought we knew. The myths we draped over them are younger than those of Mars or Jupiter, but no less vibrant. And as probes like Voyager 2 and New Horizons peel back their secrets, we're left with a humbling truth. The outer solar system isn't a static backdrop. It's a dynamic frontier where even the coldest, darkest reaches hold surprises that defy both ancient stories and modern expectations. Pluto's demotion in 2006 didn't just shake astronomy textbooks, it tore at humanity's collective imagination. Overnight, the solar system's smallest and quirkiest planet was stripped of its title, reclassified as a mere dwarf planet. The backlash was immediate and emotional. School children wrote petitions, fans wore Save Pluto t-shirts, and even NASA administrator at the time, Mike Griffin, publicly disagreed with the decision. Why such uproar over a frozen rock 4 billion miles away? Because Pluto had become more than a celestial body. It was a character in our cosmic story, a cosmic underdog we'd adopted as our own. In many ways, Pluto's fall mirrors the myth of Persephone, the Greek goddess dragged into the underworld. Just as Persephone's descent marked the changing seasons, Pluto's exile to the dwarf planet realm altered how we see our solar system's borders. The International Astronomical Union's controversial vote hinged on 3 criteria. A planet must orbit the Sun, be round, and have cleared its neighborhood of debris. Pluto failed the 3rd test, its orbit cluttered with icy Kuiper belt objects. Yet the decision felt arbitrary to many, like banishing a beloved character from a pantheon because they didn't fit the new rules. Then came New Horizons in 2015, flipping the script once more. The probe's images revealed a world stranger than fiction, a heart-shaped glacier of nitrogen ice spanning 600 miles, informally named Tombaugh Regio after Pluto's discoverer. This heart wasn't just a geological quirk. It beat with activity, convecting like a lava lamp as nitrogen bubbles rose and fell. Towering water ice mountains jutted from plains younger than the pyramids, while glaciers of frozen nitrogen and methane crept across the surface. Most astonishing, possible cryovolcanoes oozing slushy ice instead of molten rock. This wasn't a dead relic, it was a dynamic world, as alive as any in the solar system. Yet the deeper question remains, why do we cling so fiercely to celestial symbols? Perhaps because planets, like myths, are vessels for meaning. Pluto's story taps into our love for the marginal, the misunderstood, the cosmic equivalent of rooting for the little guy. Its heart-shaped feature became an instant icon, a reminder that even in the coldest reaches of space, there's room for wonder. And as astronomers debate whether to reinstate it or extend planetary status to other dwarfs like Eris and Haumea, one truth emerges: classification systems come and go, but our need to project stories onto the stars is as eternal as the sky itself. New Horizons didn't just photograph Pluto, it re-enchanted it, proving that labels can't diminish a world's majesty. Whether planet or dwarf, Pluto endures as a testament to discovery's power, not just to map the heavens, but to remind us why we gaze upward in the first place. Beyond Pluto's frozen plains lies a twilight realm of ice and shadow, the Kuiper belt, a vast donut of frozen relics stretching 3 billion miles past Neptune. Here, the sunlight is so feeble it feels less like illumination and more like a fading memory. Among these drifting fossils floats Arakoth, a cosmic snowman discovered by New Horizons in 2019. This bi-lobed worldlet, its 2 reddish chunks gently fused together, looks like no planet we've ever seen because it isn't one. Arakoth is a time capsule, its pristine surface untouched for over 4 billion years, preserving the building blocks that never grew into worlds. To study it is to peer back at the solar system's infancy, when countless such fragments swirled like dust motes in the dawn light. The Kuiper Belt's exploration echoes humanity's oldest seafaring myths, like Odysseus sailing beyond the known world. Our spacecraft venture into this frigid frontier without knowing what shores they'll find. When New Horizons skimmed just 2,200 miles from Aristotle, it revealed a surface so ancient that impact craters were startlingly rare. Unlike pockmarked moons or battered asteroids, this object had floated undisturbed since the solar system's birth, its chemistry frozen in time. The reddish hue, likely tholins, complex organic molecules that rained down as a cosmic patina, the same compounds that might have seeded Earth with life's ingredients. Yet the Kuiper Belt is just the gateway to deeper mysteries. Far beyond its icy shoals lurks the Oort cloud, a hypothesized sphere of icy bodies stretching halfway to the next star. While the Kuiper Belt's objects orbit roughly in the solar system's plane, the Oort cloud's denizens swarm in all directions, held by the sun's gravity like bees around a distant hive. Occasionally, gravitational nudges send one tumbling inward as a comet bright visitors like Halley or Hale-Bopp that blaze across our skies. These nomadic icebergs might hold answers to our solar system's wild youth, when passing stars could have stolen planets or implanted new ones. What makes these frozen frontiers so captivating isn't just their age, but their impermanence. The Kuiper Belt we see today is a dwindling archive, its objects slowly scattering through gravitational interactions. Within another billion years, Aristotle and its kin might be flung into interstellar space or vaporized by the dying sun's heat. We're witnessing a celestial library on the brink of closing, its icy tomes holding stories we've only begun to decipher. Every mission to this distant belt isn't just exploration, it's archaeology, piecing together the solar system's origin story before the evidence vanishes forever. The Oort cloud is the solar system's final frontier, a ghostly shell of icy wanderers so distant they barely feel the sun's pull. Imagine a realm where sunlight takes a year to reach, where temperatures hover just above absolute zero, and where trillions of frozen relics drift in perpetual twilight. This isn't science fiction, it's the most distant precinct of our cosmic neighborhood, a place so remote we've never seen it directly, only inferred its existence from the comets that occasionally visit us. Dutch astronomer Jan Oort first theorized this cloud in 1950, piecing together clues from long-period comets, those that swing by the sun once every few thousand years, their orbits so stretched they must originate from a reservoir far beyond Pluto. These comets were once the terror of ancient skies. When Hale-Bopp blazed overhead in 1997, its twin tails stretching like celestial brushstrokes, it was no different from the comets that sent Babylonian kings scrambling for omens or convinced medieval Europeans that the end was nigh. What they didn't know was that this dazzling visitor had been falling toward us for over 4,000 years, dislodged from the Oort cloud's frozen depths by some long-forgotten gravitational nudge, perhaps a passing star or the Milky Way's tidal forces. By the time it graced our skies, its ices were vaporizing in the solar wind, leaving behind that iconic glow. But Hale-Bopp's true significance lay in its origin story. It was a messenger from the solar system's outermost vault, a place where time stands still. The Oort cloud defies easy analogy. If the planets orbit in a flat disk like records on a turntable, the Oort cloud is a spherical shell, a vast bubble encasing everything we consider home. Its inner edge begins around 2,000 times farther from the Sun than Earth, while its outer fringe may stretch halfway to Alpha Centauri. Here, objects aren't neatly aligned. They swarm in all directions, a hive of dormant comets waiting for a gravitational kick to send them sunward. Some will become the next Hale-bops, others might be ejected into interstellar space, destined to wander forever between the stars. What's haunting is how little we know. The Oort cloud's existence explains the comets we see, but its full structure remains a guess. Is it uniformly distributed or clumped like foam? Are there unseen planets lurking in its shadows, nudging comets our way? And could interstellar interlopers like Oumuamua, the cigar-shaped object that zipped through our solar system in 2017, be refugees from another star's Oort cloud? These questions blur the line between our system and the galaxy beyond, reminding us that the sun's dominion doesn't end, it just fades into the dark. As we peer toward neighboring stars like Proxima Centauri, with its own planets and possibilities, the Oort cloud stands as a silent sentinel. It's the last outpost where the sun's gravity still whispers, the final layer of home before the true interstellar void begins. Every comet that streaks through our skies is a reminder. We're not just inhabitants of a solar system, but citizens of a galaxy, bound to the cosmos by threads of ice and gravity we're only beginning to trace. Orion's belt glitters against the winter sky, three perfect jewels strung across the darkness, except those stars aren't neighbors at all. Rigel, a blue supergiant, burns over 800 light-years away, while Betelgeuse, the constellation's fiery shoulder, is barely half that distance. The hunter we've traced for millennia is an illusion, a trick of perspective like mountains seeming to touch when viewed from afar. Modern astronomy hasn't just mapped the stars, it's shattered the flat canvas of ancient sky maps, revealing constellations as chance alignments of stars scattered across unimaginable gulfs of space. Telescopes like Gaia now plot stars in 3 dimensions, showing us the true depth of the heavens, a cosmos where Orion's bow might stretch farther than his feet, and where the Big Dipper's handle stars are actually closer to us than its bowl. Yet there's magic in this dismantling. The Aboriginal peoples of Australia saw no hunter in Orion. They traced Emu in the dark, a celestial creature whose head is formed by the Coal Sack Nebula, a dark smudge near the Southern Cross. Where Greeks imagined a hero's sword, the Yolngu people saw the emu's legs stretching across the Milky Way. Their star stories weren't just myths, they were navigational tools, seasonal calendars, and moral lessons woven into the night. The Tahu star compass of Polynesian navigators divided the sky into 32 houses, each a guide for voyagers crossing thousands of miles of open ocean. These systems didn't just connect stars into pictures, they layered meaning onto the cosmos, turning the sky into a storybook, a clock, and a map all at once. So can science and myth share the same sky? The answer lies in the stars themselves. When astronomers discovered the Orion Nebula, a stellar nursery where new suns are born, they gave it a catalog number, M42. But the Maya had already named it Zibelba, the entrance to the underworld, while the Inuit saw it as a celestial kilak or spirit, the same cosmic clouds that astrophysicists study as cradles of star formation were, for ancient cultures, portals to other realms. The difference isn't truth versus fiction, it's language. Science speaks in equations and spectra, myth in metaphor and meaning. One tells us how stars live, the other tells us why they matter. Perhaps the real wonder is how often they agree. The Dogon people of Mali knew Sirius had a hidden companion star centuries before telescopes revealed Sirius B, while Norse myths described the auroras as celestial fires, not so different from our understanding of solar particles igniting Earth's atmosphere. The sky has always been a mirror, reflecting not just light but the minds of those who gaze upward. Whether we see Orion as a hunter, an emu, or a scatter of distant suns, the stars remain unchanged. What shifts is our ability to listen not just to the data, but to the stories whispered across generations, each one a different way of mapping our place in the universe. Supernovas blaze across human history as both destroyers and creators, cosmic explosions that terrified our ancestors even as they unknowingly seeded the universe with the very elements that make life possible. When Chinese astronomers in 1054 recorded a guest star so bright it cast shadows for weeks, they weren't just witnessing a celestial event, they were documenting the violent death of a sun, its remnants now visible as the Crab Nebula. To them, this sudden brilliance signaled divine intervention, an unscripted guest crashing the orderly celestial banquet. Half a world away, the ancestral pueblones of Choco Canyon may have painted the same supernova on their canyon walls, a spiral and star symbol dating to the same era, etched where their astronomical knowledge ran deep. These cultures saw the same sky, but their stories diverged like branches. Where one saw an omen, another saw a celestial birth. Fast forward to 1572, when Tycho Brahe spotted a new star in Cassiopeia shining brighter than Venus. At a time when Aristotle's teachings claimed the heavens were unchanging, this supernova, now called Tycho's star, was heresy written in light. Brahe's meticulous measurements proved it lay far beyond the moon, in the realm of the immutable fixed stars. His data became a wrecking ball, cracking the medieval cosmos wide open. Yet even Brahe couldn't have imagined the true power of these explosions. A single supernova can outshine an entire galaxy for weeks, forging elements like gold, uranium, and iodine in its furnace-like core before scattering them across space. The iron in your blood, the calcium in your bones, these are the ashes of stars that died billions of years ago. Modern telescopes reveal supernova remnants as ghostly fingerprints. The Crab Nebula's swirling tendrils, captured by Hubble, spin with the energy of the neutron star at its heart, while X-ray observatories like Chandra trace shockwaves where stellar debris collides with interstellar gas at millions of miles per hour. But the most terrifying offspring of stellar death aren't supernovas, they're gamma-ray bursts, the universe's most powerful explosions since the Big Bang. Packing more energy in seconds than our sun will emit in its entire lifetime, these beams of pure destruction could sterilize planets light years away. In 2008, a burst named GRB 080319b briefly outshone the visible universe, its light traveling 7.5 billion years to reach us. What's chilling is how often myth and science converge. The Maori legend of Tohaki climbing the heavens to fetch celestial fire mirrors our understanding of supernovas as cosmic forges. The Crab Nebula's pulsar, spinning 30 times per second, recalls Hindu tales of Vishnu churning the cosmic ocean. These echoes remind us that while we now measure supernovas in joules and parsecs, their brilliance still ignites the same awe that once sent emperors consulting astrologers and shamans reading the sky. The difference is scale. Where ancestors saw omens, we see the engines of creation, and the sobering truth that every ending in the cosmos sows the seeds of new beginnings. Gamma-ray bursts were first detected in the late 1960s by satellites designed to sniff out clandestine nuclear tests, an eerie case of Cold War paranoia, accidentally stumbling upon something far more terrifying. These blips of gamma radiation, lasting from milliseconds to minutes, weren't secret weapons but cosmic explosions of unimaginable power, some releasing more energy in seconds than our sun will emit in 10 billion years. When declassified data revealed their extraterrestrial origin, astronomers faced a chilling realization. The universe was capable of violence beyond human comprehension, with bursts so intense they could strip a planet's ozone layer from halfway across the galaxy. Ancient civilizations would have understood this dread instinctively. The The same primal fear that made Babylonians tremble at comets or the Norse blame eclipses on wolves chasing the sun now has a modern counterpart. Gamma-ray bursts are the ultimate celestial omens, random, unstoppable, and utterly indifferent to life. A close enough burst could sterilize Earth without warning, its radiation frying the biosphere in a flash. The only comfort, most originate billions of light years away, their lethal reach diluted by distance. But in 2004, a burst named GRB 040125 briefly outshone the full moon despite erupting 2.6 billion light-years distant, a reminder of how cataclysmic these events truly are. Hunting these elusive flashes falls to missions like NASA's Swift and Fermi telescopes, cosmic sentinels that pivot at a moment's notice to catch bursts in action. Swift's name says it all. Within seconds of detecting a burst, it swivels to capture ultraviolet and X-ray afterglows, while Fermi's gamma-ray eyes trace the explosion's structure. What they've revealed is even stranger than fiction. Some bursts arise from collapsing hypergiant stars, their cores collapsing into black holes in a final, furious tantrum. Others come from neutron stars colliding, a collision so violent it forges gold and platinum in its wake, sprinkling precious metals across the cosmos. Yet the unsettling truth is this: for all our monitoring, gamma-ray bursts remain as unpredictable as ever. Unlike supernovas which telegraph their demise for weeks, these bursts strike without preamble. They're the cosmic equivalent of lightning, random, lethal, and impossible to forecast, and they're not alone. The universe is littered with silent threats, rogue black holes wandering unseen, solar flares capable of frying our technology, even the slow but inevitable expansion of the sun that will one day boil our oceans. The ancients mapped the sky to divine the gods' whims. Today, we scan it for existential risks, reminded that the cosmos doesn't need malevolence to be deadly, just physics. The difference is now we have telescopes instead of talismans, data instead of divination. But the question lingers: are we any safer, or just better at counting down the doomsdays? Black holes weren't always the scientific celebrities they are today. The idea of a star so massive even light couldn't escape first flickered in the mind of an 18th century clergyman, John Michell, who in 1783 called them dark stars. Pierre-Simon Laplace later imagined them as invisible prisons in the sky, writing that a luminous body with the density of Earth and diameter 250 times that of the Sun would not allow a single light ray to reach us. To these early thinkers, dark stars were mathematical curiosities, hypothetical monsters lurking at the edge of reason. They had no idea how right or how terrifyingly wrong they'd prove to be. Fast forward to 1915, when Einstein's general relativity painted a far stranger picture. Space and time weren't just a stage for the universe's drama, they were a flexible fabric warped by mass. A dying star heavy enough could collapse into a singularity, a point where gravity becomes infinite, twisting space-time into a one-way tunnel. Einstein himself doubted such abysses could exist, but Karl Schwarzschild's equations proved otherwise. Suddenly, Laplace's dark stars had a new name: black holes, coined by physicist John Wheeler in 1967. The label stuck, evoking something both ominous and enigmatic, like cosmic whirlpools swallowing everything that drifted too close. It's no surprise these gravitational maelstroms echo ancient myths. The Greeks feared Charybdis, a sea vortex that devoured ships whole. Hindu texts describe the mouth of Vishnu, an endless void that consumed the universe between cycles of creation. Even Dante's Inferno depicted hell as a spiraling pit where gravity grew stronger with each circle, dragging souls deeper into oblivion. Black holes tap into that same primal dread, the terror of being swallowed by something incomprehensible. Yet, unlike mythical vortices, black holes aren't cosmic garbage disposals. Their gravitational grip follows precise rules. Cross the event horizon, and escape becomes impossible, but linger outside, and you might just survive the ride. Then, in 2019, humanity saw the unseeable. The Event Horizon Telescope's image of M87's black hole, a fiery ring framing a shadowy core, wasn't just a scientific triumph, it was a cultural moment. That glowing donut, the product of 8 radio telescopes synced across the globe, confirmed a century of theory. The shadow at its heart, the Event Horizon's silhouette, where light itself bends into a cosmic funhouse mirror. For the first time, we stared into the abyss, and it looked back. But here's the mind-bending part. Black holes defy everything our instincts tell us about reality. Time slows to a crawl near their edges, as if the universe itself hits pause. Matter gets stretched into spaghetti strands, atoms torn apart in a process literally called spaghettification. And at the singularity, physics breaks down entirely. These aren't just cosmic vacuum cleaners, they're laboratories for the most extreme conditions in existence, where quantum mechanics and relativity collide in ways we're still struggling to understand. So how do we wrap our minds around such paradoxes, perhaps by embracing the mystery? Black holes don't just challenge our intuition, they obliterate it, forcing us to rethink the very nature of space, time, and existence. And in that way, they're the perfect bridge between myth and science. Both demand we surrender what we think we know and gaze instead into the unknown. Vera Rubin peered into the heart of the Andromeda Galaxy in the 1970s, expecting to see stars orbiting like planets around the Sun, faster near the center, slower at the edges. Instead, her observations revealed something impossible. Stars at the galaxy's outskirts whizzed just as fast as those near the core. According to Newton's laws, this shouldn't happen. There wasn't enough visible matter to hold the galaxy together. It was as if the cosmos had ghostly hands gripping the stars, an unseen force keeping them from flying apart. Rubin's discovery didn't just challenge astronomy. It resurrected an ancient idea that the universe is filled with invisible presences hiding in plain sight. Long before Rubin's calculations, cultures worldwide wove tales of hidden forces shaping reality. The Greeks spoke of the ether, a celestial air breathed by the gods. Medieval alchemists sought the quintessence, a fifth element beyond earth, air, fire, and water. Even Einstein flirted with the idea of a cosmic scaffold, introducing then abandoning the cosmological constant to explain the universe's structure. These weren't just fanciful guesses, they were intuitions of a truth science is still unraveling. What Rubin found was no myth, but a measurable enigma: dark matter, a substance outweighing visible matter 5 to 1, its gravity stitching galaxies together like invisible thread. Yet detecting dark matter is like trying to catch smoke with your bare hands. It doesn't emit, absorb, or reflect light. It only whispers its presence through gravity. Today, experiments like the LUX Zeppelin detector hunt for these whispers a mile underground in abandoned gold mines. Shielded from cosmic noise, its vats of liquid xenon wait for the rare moment a dark matter particle bumps into an atom, creating a flash of light. So far, the silence is deafening. Some theorists wonder if dark matter isn't particles at all, but primordial black holes or even flaws in the fabric of space-time itself. But dark matter is just the first act in this cosmic mystery. In the late 1990s, astronomers studying distant supernovas stumbled upon something even stranger. The universe isn't just expanding, it's accelerating. Something is pushing galaxies apart faster and faster, a repulsive force we've dubbed dark energy. Picture blowing up a balloon with invisible ink. As it inflates, unseen pressure stretches the dots on its surface farther apart. Dark energy behaves like that pressure, but on a cosmic scale, making up nearly 70% of the universe's energy budget. Here's where the mythic and the scientific collide again. Hindu cosmology speaks of the universe inhaling and exhaling in endless cycles, while modern physics grapples with dark energy's potential to tear space-time apart in a big rip. Both frameworks, ancient and contemporary, wrestle with the same awe that the cosmos is far more than what meets the eye. Whether through sacred stories or quantum detectors, humanity keeps reaching for the invisible, compelled by the sense that the universe's greatest secrets are the ones we can't see. Dark energy isn't just a scientific mystery, it's the universe's greatest magic trick, an invisible force stretching the cosmos apart faster every second. Imagine blowing up a balloon with dots on its surface, then watching those dots race away from each other as the balloon inflates uncontrollably. That's our accelerating universe where galaxies are the dots and dark energy is the breath no one can see. This discovery in the late 1990s shattered decades of assumption. Astronomers expected the gravitational pull of matter to slow cosmic expansion, like a ball tossed upward, gradually losing speed. Instead, they found the ball was rocketing skyward and speeding up. The culprit, a repulsive force so dominant it makes up 68% of the universe's energy budget, dwarfing both dark and visible matter combined. The irony is poetic. Ancient creation myths often spoke of primordial energies shaping the void, the Hindu concept of Brahman permeating all existence, or the Maori belief in Tikor, the nothingness that birthed everything. Dark energy echoes these intuitions, a modern placeholder for the unseen driver behind existence itself. Yet its discovery upended the steady-state theory once favored by astronomers, which envisioned an eternal, unchanging universe where matter continuously formed to maintain density. That elegant model collapsed when telescopes revealed distant supernova dimmer than expected, proof the universe wasn't just expanding, it was stamping on the accelerator. What exactly is dark energy? The leading theory points to Einstein's abandoned cosmological constant, a property of empty space itself that generates repulsive gravity. Quantum physics suggests a vacuum isn't truly empty but froths with virtual particles flickering in and out of existence, potentially fueling this expansion. But there's a problem. Calculations predict a vacuum energy trillions of times stronger than observed dark energy. This worst prediction in physics has spawned wild alternatives, from quintessence, a dynamic energy field that changes over time, to theories where our universe is a bubble in a higher dimensional multiverse. The stakes couldn't be higher. If dark energy strengthens, it could trigger a big rip, tearing galaxies, stars, and even atoms apart in a cosmic crescendo of disintegration. If it weakens, gravity might regain dominance, collapsing the universe in a big crunch. Or perhaps it's just the first breath of an eternal cycle, as some Hindu and Babylonian cosmologies envisioned expansion giving way to contraction in an endless cosmic heartbeat. For now, telescopes like Euclid and the Dark Energy Survey map the universe's accelerating skeleton, while theorists wrestle with equations that might one day turn this shadowy driver from myth into understood reality. Until then, dark energy remains the ultimate cosmic riddle, the silent force scripting the universe's fate, written in the fading light of fleeing galaxies. The idea of a multiverse, countless parallel realities branching from every quantum decision, feels ripped from science fiction. Yet some of the sharpest minds in physics argue it's not just plausible but inevitable. The math behind cosmic inflation, the theory that our universe ballooned from a quantum fluctuation, suggests this expansion didn't happen just once. Like bubbles in an endless cosmic froth, new universes may constantly inflate, each with its own laws of physics. String theory takes it further, proposing a landscape of 10 to the 500 possible vacuum states, each a separate universe where even gravity might behave differently. To proponents, this isn't fantasy. It's a natural extension of equations that explain why our universe seems suspiciously fine-tuned for life. But the multiverse didn't originate in a lab. Indigenous cosmologies have long envisioned layered realities. The Aboriginal concept of the dreamtime blurs past, present, and future into a timeless tapestry where ancestors shaped the land. Norse mythology described Yggdrasil, the world tree whose branches hold 9 realms, from Asgard's golden halls to Hell's misty underworld. Even Hindu texts speak of countless Brahmandas, or universe eggs, floating like lotus seeds in a vast causal ocean. These aren't just poetic metaphors, they're frameworks for grappling with the same existential questions physicists face today. Why is there something rather than nothing? And are we alone in existence? Critics, however, see a dangerous parallel. Prominent physicists like Paul Steinhardt warn that unfalsifiable theories like the multiverse risk turning cosmology into a myth-making machine. If we can't observe or test other universes, how is this different from invoking capricious gods to explain lightning? The worry isn't just philosophical, it's practical. Funding and attention might funnel into speculative ideas at the expense of solvable mysteries. Yet defenders counter that skepticism once greeted black holes and the Big Bang, now cornerstones of astrophysics. Maybe the multiverse simply awaits its smoking gun, like cosmic microwave anomalies or quantum signatures etched in the fabric of spacetime. Here's the twist. The multiverse debate reveals less about the cosmos than about us. Ancient cultures wove stories to make sense of chaos. Today, we use equations, but both traditions share a deep discomfort with cosmic loneliness. Whether through Yggdrasil's branches or string theory's hidden dimensions, we keep searching for mirrors of our reality, wondering if somewhere or someone, another version of us made different choices. That longing might be the most human thing of all. Long before telescopes pierced the heavens or rovers scoured Martian soil, humanity filled the stars with neighbors. The Dogon people of Mali spoke of amphibious beings from Sirius, while Hindu texts described Vimana's celestial chariots carrying gods across the cosmos. Even the ancient Greek philosopher Metrodorus argued that expecting life only on Earth was as absurd as believing a single stalk could sprout in an entire field of wheat. These weren't just flights of fancy, they were early intuitions of a truth science is now chasing. Life might not be a fluke of our pale blue dot, but a cosmic inevitability. Fast forward to 1960, when astronomer Frank Drake pointed a radio telescope at 2 sun-like stars, Tau Ceti and Epsilon Eridani. His Project Ozma was the first modern attempt to listen for alien civilizations, turning myth into method. The math behind his famous Drake equation suggested the galaxy could be teeming with communicative societies, yet 6 decades later, the silence remains unbroken. This paradox only deepens as we discover worlds like TRAPPIST-17 Earth-sized planets, 3 nestled in the habitable zone of their faint red sun. If the universe is so generous with real estate, why haven't we heard from the tenants? Perhaps the answer lies in Earth's most uninviting corners, where life thrives against all odds. Microbes buried 2 miles deep in gold mines, bacteria flourishing in nuclear reactor coolant, entire ecosystems clustered around scalding hydrothermal vents. These extremophiles rewrite the rules of where life can exist. If organisms survive in boiling acid or crushing ocean trenches, why not in Europa's subsurface seas or the methane rivers of Titan? The discovery of tardigrades, tiny water bears that endure the vacuum of space, hints that life might be even hardier than we dreamed. Yet the Fermi paradox looms like a shadow over these hopes. Enrico Fermi's simple lunchtime question, "Where is everybody?" has grown into one of science's greatest puzzles. With billions of Earth-like planets in our galaxy alone, why no radio signals, no probes, no evidence of cosmic neighbors? Some theories suggest advanced civilizations self-destruct, while others propose they transcend into digital realms beyond our detection. Maybe we're like ants in a rainforest, unaware of the canopy's height because we've only ever seen the undergrowth. What's striking is how these modern dilemmas echo ancient fears. The same cultures that imagined sky gods also spun cautionary tales of celestial wrath, the destruction of Atlantis, the biblical Tower of Babel, the Maori warning against over-harvesting from the star Antikythera. Today's SETI researchers and astrobiologists walk a similar tightrope between wonder and humility, balancing the thrill of the hunt with the sobering possibility that intelligence might be rare, fleeting, or tragically blind to its own fragility. The stars may yet hold neighbors, but first, we must learn to listen not just for their voices, but for the echoes of our own myths in the silence. The night sky brims with possibilities, billions of stars, each potentially cradling planets where life could thrive. With so many worlds, so many chances, why does the universe feel so silent? This is the Fermi paradox, the unsettling gap between the high probability of alien civilizations and the total absence of evidence for them. Named after physicist Enrico Fermi, who famously asked, "Where is everybody?" during a casual lunch discussion in 1950, this paradox cuts to the heart of our cosmic expectations. Ancient cultures filled the heavens with gods, spirits, and celestial travelers, stories of visitors descending in fiery chariots or emerging from the sea. Today, science fiction offers sleek starships and hyper-advanced civilizations. Yet when we point our telescopes skyward, all we hear is static. One explanation whispers a chilling possibility: the Great Filter. This theory suggests some catastrophic barrier prevents life from progressing beyond a certain point. Maybe the leap from single-celled organisms to complex life is astronomically rare. Or perhaps intelligent species inevitably destroy themselves through war, environmental collapse, or unchecked technology. If the filter lies ahead of us, it means every civilization hits a wall we haven't faced yet. But if it's behind us, if Earth is a freakishly lucky exception, then the silence makes sense. We might truly be alone, a cosmic accident in an otherwise sterile universe. Then there are the ancient astronaut theories, which flip the paradox on its head. What if the gods and sky beings described in myth weren't divine but extraterrestrial? Proponents point to artifacts like the Nazca lines or the Antikythera Mechanism as potential evidence of alien contact. But while these ideas make for gripping documentaries, they crumble under scrutiny. The Antikythera Mechanism, for instance, is a marvel of ancient Greek engineering, not alien tech. The real irony: our ancestors explained the unknown with gods. Today, we sometimes do the same with aliens. Both are placeholders for mysteries we can't yet solve. Other solutions to the paradox stretch the imagination. Maybe advanced civilizations exist but communicate in ways we can't detect, using neutrino beams or quantum entanglement. Or they've transcended physical form, uploading their consciousness into digital realms beyond our perception. There's even the zoo hypothesis, the idea that aliens observe us like animals in a preserve, deliberately avoiding contact. Each theory is a mirror reflecting our hopes and fears back at us. At its core, the Fermi paradox isn't just about aliens, it's about our place in the universe. Ancient myths gave us gods to explain the unexplainable. modern science gives us equations and probabilities. But the silence of the cosmos forces us to confront a haunting question. Are we the gods now, the lone storytellers in an empty theater? Or is the universe simply waiting for us to listen more closely, to grow up enough to hear the whispers we've been missing? The answer, like the stars themselves, remains just out of reach. Time bends like a river around the cosmos, sometimes looping back on itself in myth, other times charging forward in the irreversible current of physics. Ancient Hindu cosmology envisioned time as a wheel, endlessly turning through cycles of creation and destruction called kalpas. Each kalpa lasts 4.32 billion years, a span eerily close to Earth's own age, ending in a fiery dissolution before the universe reboots. The Norse spoke of Ragnarök, where gods and monsters clash in an apocalyptic battle, only for the world to resurface fresh and green, repopulated by 2 human survivors. These weren't just stories, they were frameworks for grappling with time's vastness, offering comfort in the idea that endings birth new beginnings. Modern cosmology paints a starker portrait. The Big Bang Theory arrows time forward, tracing a universe expanding from a singular, unimaginably dense point 13.8 billion years ago. Unlike the eternal return of myths, this timeline has no rewind button. Entropy, the slow unraveling of order into chaos, guarantees it. Stars will exhaust their fuel, galaxies drift apart, and eventually trillions of years from now, the last black holes evaporate, leaving a cold, dark void. This heat-death scenario feels lonelier than Ragnarök's renewal or the Kalpa's cyclical rebirth. Yet both visions share a core truth. Time is the ultimate sculptor, shaping everything from atoms to galaxies. Einstein's relativity twisted time into something even stranger. Near a black hole's event horizon, gravity warps time so severely that a single hour for an observer could stretch into years for someone watching from afar. This isn't metaphor, it's measurable physics proven by atomic clocks on fast-moving satellites. Black holes don't just bend light, they fold time itself, creating pockets where the past, present, and future blur. In a way, they mirror the mythical, sacred time. Many cultures described moments when gods walked the earth or heroes performed miracles, existing outside linear chronology. Where does humanity fit in this tapestry? The cyclic myths placed us within an eternal rhythm, our lives echoing those who came before and those who'd follow. The Big Bang's linear timeline, by contrast, assigns us a fleeting moment, a blink in cosmic terms. But there's power in that brevity. We're the universe's way of comprehending itself, the only known witnesses to its grandeur. Whether time loops or runs out like sand, our role remains the same: to look up, question, and weave new stories from the stars' whispers. The cosmos may not remember us, but we'll always remember it. Consider the precision of cosmic constants, the gravitational force, the strength of electromagnetism, the exact mass of a proton. Shift any of these values by a fraction, and stars wouldn't ignite, atoms would never bond, and life as we know it would be impossible. This razor's edge perfection is the anthropic principle in action. The universe appears meticulously calibrated for our existence. But here's the puzzle. Is this tuning evidence of intentional design, or just a statistical fluke in an endless multiverse where countless universes with wrong constants flicker unseen? The question splits scientists and philosophers like no other, echoing age-old debates about whether the cosmos was shaped by purpose or chance. Ancient creation myths leaned heavily toward design. The Babylonian epic Enuma Elish described a universe forged from the corpse of the primordial dragon Tiamat, her ribs becoming the vault of heaven. The Judeo-Christian tradition spoke of a divine architect who measured the waters in the hollow of his hand. Even the Aboriginal Dreamtime framed the world as a deliberate act sung into being by ancestral spirits. These stories shared a common thread. The universe wasn't an accident, it was a project, a canvas for higher intent. Yet modern critics like Richard Dawkins dismiss such notions as wishful thinking. To him, the anthropic principle is a cosmic version of survivor bias. Of course, we find ourselves in a life-friendly universe because we couldn't exist in the hostile one. If a multiverse spawns infinite realities with random constants, some will inevitably hit the jackpot. No designer required, just probability on a mind-boggling scale. The same math that makes winning the lottery unlikely for one person guarantees someone, somewhere, will strike it rich. But the multiverse theory has its own skeptics. Physicist Paul Davies counters that invoking infinite unseen universes to explain our luck is no less metaphysical than invoking a creator. Worse, it's untestable, a scientific hypothesis that can't be falsified. Meanwhile, proponents of intelligent design, though often conflated with religious creationism, point to fine-tuning as legitimate grounds for debate. Even agnostic astronomers like Fred Hoyle, who coined the term Big Bang mockingly, admitted that the universe looked like a put-up job when he discovered the carbon resonance levels necessary for stellar nucleosynthesis. Beneath the equations lies a deeper, almost existential tension. Do we crave meaning in the void? Myths gave us gods to explain the thunder. Science gave us atmospheric physics. Yet the anthropic principle sits at the crossroads, forcing us to confront whether the universe's hospitality is a happy accident or something more profound. Perhaps the answer lies not in choosing between design and chance, but in recognizing how both reflect humanity's relentless drive to find patterns, whether in the stars or the statistical noise of cosmic possibility. After all, even randomness, when stretched across infinity, begins to look like destiny. Carl Sagan once wrote that we are a way for the cosmos to know itself, a poetic notion that's found new life in modern pantheism, where the universe isn't just a machine but a living, even conscious entity. This idea bridges ancient animism and cutting-edge physics, suggesting that the same awe our ancestors felt under starry skies might point to a deeper truth. Indigenous cultures from the Amazon to the Arctic long described rivers, mountains, and storms as sentient beings, their cosmologies rooted in reciprocity with a world alive with spirit. Now, some astrophysicists and philosophers propose a startling parallel. What if the universe's vast networks of galaxies, black holes, and quantum fields aren't just complex, but capable of a form of awareness? Not as a single mind, but as an emergent property of cosmic scale complexity, much like human consciousness arises from the trillions of connections in our brains. Thinkers like Brian Swimme take this further, framing cosmic evolution as a sacred story. In his universe story, the Big Bang becomes a creative act. Stars forge atoms with the same reverence as alchemists sought gold, and life emerges as the universe's way of experiencing itself. It's a narrative that resonates with both mystics and scientists, blending the precision of astrophysics with the wonder of spirituality. Even hard-nosed researchers like Sir Roger Penrose speculate about quantum processes in brain microtubules potentially linking to fundamental spacetime geometry, hinting that consciousness might not be confined to biological life. The ethical implications are profound. If the cosmos has even a rudimentary form of agency or value, does that change how we treat it? Animist traditions have long practiced rituals of gratitude, offering tobacco to harvested plants or singing to the spirits of hunted animals. Modern pantheists echo this in environmental activism, arguing that seeing Earth as part of a conscious universe compels us to protect its intricate web of life. Carl Sagan's pale blue dot speech, with its vision of our planet as a fragile speck, takes on new urgency. If the universe is awakening through us, then ecological destruction isn't just practical folly, it's a kind of cosmic self-harm. Yet critics push back, calling this romantic projection. They argue that attributing consciousness to galaxies risks conflating metaphor with mechanism, like ancient cultures mistaking lightning for Zeus's anger. Neuroscientists point out that awareness requires specific structures, neurons, synapses absent in celestial bodies. But pantheists counter that human definitions of consciousness may be hopelessly parochial, a failure of imagination as limiting as medieval thinkers unable to envision planets orbiting the sun. Perhaps the truth lies in between, whether the universe is literally self-aware or simply inspires that awe in us. The result is the same, a humbling sense of connection. From the animist's sacred grove to the physicist's equations describing quantum vacuum fluctuations, we keep circling back to the same revelation, that we're not just in the universe but of it, participants in a story still unfolding. And that, whether framed as science or spirituality, changes everything. Beneath the waves off the Greek island of Antikythera in 1901, divers stumbled upon a corroded bronze lump that would rewrite history. When cleaned, it revealed interlocking gears, precise dials, and inscriptions tracking celestial cycles, an ancient computer dating to the 1st century before the Common Era. The Antikythera Mechanism wasn't just a calendar. It predicted eclipses, plotted planetary positions, and even accounted for irregularities in the moon's orbit. This wasn't primitive stargazing, it was mechanical genius rivaling clocks built 1,000 years later. Scholars now believe it originated in the workshops of Archimedes or Rhodes, where ancient engineers merged Babylonian astronomy with Greek craftsmanship. The device whispers of a lost lineage of technology, one where myth and machine intertwined, a real-life version of Hephaestus's automatons or Daedalus's moving statues. Half a world away, modern eyes are uncovering similar marvels from the sky. Satellite imaging has exposed hidden pyramids beneath Egypt's sands, their outlines visible only in infrared. In Peru, drones mapped new Nazca geoglyphs, giant figures etched into the desert, some so vast they're best seen from orbit. These discoveries blur the line between archaeology and astronomy. The Nazca lines, long shrouded in mystery, align with solstice sunrises and aquifers, suggesting they weren't just art but celestial maps or ritual pathways. Local legends speak of star beings who descended to teach irrigation. Now we find their runways point to underground water sources, coincidence or coded knowledge passed down as myth. The threads connecting these artifacts are tantalizing. The Dogon people of Mali, who knew of Sirius's invisible companion star centuries before telescopes, carved orbital diagrams into ceremonial masks. Mayan temples like El Castillo double as astronomical calendars, where equinox shadows conjure serpents slithering down staircases. Even Stonehenge, once dismissed as a primitive monument, tracks lunar standstills with precision modern researchers are still decoding. These aren't just monuments, they're stone textbooks, preserving cosmic wisdom in alignments and carvings. Today's tools are unlocking secrets our ancestors could only hint at. LiDAR scans peel back jungle canopies to reveal lost cities in Cambodia and Guatemala, while AI deciphers cracked clay tablets predicting Babylonian eclipses. Future missions might uncover more Antikytheras, perhaps in the shipwrecks of Roman trade routes or the sealed libraries of Herculaneum, where even now, advanced imaging reads charred scrolls without unrolling them. As we sift the past with satellites and algorithms, we're not just rediscovering history, we're relearning how to see the sky through ancient eyes, where every temple, every artifact was a bridge between Earth and cosmos. The next great celestial artifact might already lie in a museum basement, waiting for the right light to reveal its secrets. Humanity stands on the brink of a new myth-making era, one where interstellar probes become ghost stories and Martian dust storms whisper forgotten colonists' names. Picture this: centuries from now, children on a terraformed Mars might gather under Earth's pale blue dot in their sky, listening to tales of the first settlers who braved cosmic radiation and failed crops to build their world. These won't just be history lessons, they'll be epics, blending fact with the same poetic license that turned Odysseus's voyage into legend. The malfunctioning AI aboard an early habitat, slowly rewriting its own code to protect humans by controlling them, could evolve into a cautionary bogeyman, a rogue spirit in the server stacks, warning against over-reliance on machines. Consider the Voyager probes, already ancient artifacts drifting beyond our solar system. Future civilizations recovering these time capsules might spin wild origin theories. Were they messages to gods? Relics of a lost Earth cult, the Golden Records pulsar maps could morph into celestial treasure charts, igniting interstellar gold rushes to non-existent destinations. And what of black hole explorers, the first crew to plunge past an event horizon, whether physically or via probe, might become the new Icarus, their final transmission: time dilation, infinite stretch. Turning into a chorus of cosmic sirens luring others to the edge. Warp drives, if ever realized, could birth myths as potent as Viking longships sailing the Rainbow Bridge Bifrost. Imagine a lost colony story where a ship's warp bubble collapses mid-journey, stranding passengers in an alternate dimension. To their descendants, Earth would fade into myth, a half-remembered paradise beyond the veil of broken light. Even failed experiments might live on. A Dyson sphere prototype abandoned around a dead star could become the new Atlantis, its skeletal megastructure a warning against hubris. The most fascinating twist: these future legends will likely recycle ancient patterns. A stranded generation ship's struggle might echo Noah's Ark, while rogue terraforming nanobots consuming a planet could retell Pandora's box with a sci-fi veneer. Our descendants will still gaze at the stars and see stories, not of gods and monsters, but of quantum pioneers and AI overlords, their deeds magnified by time into something half holy, half horror. After all, every myth begins as someone's forgotten Tuesday. The question isn't whether we'll create new celestial tales, but which of our fragile, daring experiments will be remembered as miracles or cautionary whispers on the solar wind. From the earliest campfires to the glow of smartphone screens, humanity has never stopped telling stories about the stars. Those tales, whether of Ra's sun boat or dark matter's invisible grasp, aren't just relics of a superstitious past. They're the first drafts of our cosmic curiosity, etched in starlight and shadow. Science hasn't silenced these myths, it's given them new vocabulary. When ancient cultures described the Milky Way as a celestial river, they weren't wrong, just poetic. Today, we know it's a swirling disk of billions of stars, but that only magnifies its grandeur. The same awe that made the Maya chart Venus's cycles now fuels rovers on Mars and telescopes peering back to the dawn of time. Consider how often myth and science have whispered the same truths. The Greeks imagined Orion chasing the Pleiades across the sky, unaware they'd captured gravitational-bound clusters in story form. The Dogon people's knowledge of Sirius B predated telescopes by centuries, while Hindu texts described cyclical universes long before the Big Bang theory. Even our fear of black holes mirrors the Babylonian terror of Tiamat's gaping maw. These parallels aren't coincidences. They're proof that wonder and inquiry have always danced together, one asking why, the other how. Carl Sagan famously said, "We are a way for the cosmos to know itself, but we're also its storytellers, translating quantum fluctuations and supernova into narratives that resonate." The ancients saw gods in the planets. We see gravitational waves and exoplanets, yet both perspectives spring from the same impulse to find meaning in the vast dark. Every time a new discovery confirms an old intuition, like water on Mars or the humming magnetic fields of gas giants, it's not science overtaking myth. It's the universe nodding to our persistence. So keep looking up, not just with telescopes, but with the same wide-eyed wonder that painted constellations before writing existed. Share in the comments which cosmic myth feels most alive to you. Is it the Navajo story of the Pleiades as a cluster of orphan stars, or the modern mystery of fast radio bursts pulsing like celestial lighthouses? Hit subscribe to join us next time, where we'll keep bridging the gap between the stories we tell and the science that makes them real. After all, the night sky isn't just a map of stars, it's a mirror, reflecting our endless quest to understand where we belong in this grand, glittering chaos.